Algebra 2, Unit 2, Lesson 5. This is modeling direct variation. So when we get an equation like this, y equals a times x, this is going to represent direct variation. So what does that mean? Again, between x and y is said to vary directly with x. Now, important to note, a cannot equal 0. And again, because anything times 0 equals 0. But we call a the constant of variation. So again, here's a quick example. If I've got my graph, so just draw something up real quick. Say I've got something like this. I might have the equation y equals 1/2 x. So again, rise over run, up 1 over 2, rise over 1. I can go down 1 to the left 2. Okay, so this is my equation y equals 1/2 x. So again, our constant of variation would be 1/2. In a similar but slightly different example, we might have something like y equals negative x. Didn't make the straight line for me. That's all right. And again, this would be y equals negative x, which my constant of variation, again, if there's no number, it's like saying -1. So my constant of variation is -1. So let's assume that we get a graph, and the question is, write and graph a direct variation equation that has -4, 8 as a solution. So I'm going to say, all right, I got a graph -4, 8. So I'm going to count by 2's, 2, 4, 6, 8, -2, -4, -6. So -4, 8 is up here. And then it's going to go through 0 as well. So again, my line's going to look something like this. Oh, shoot. Can I move it? I think I can move it. Nope. All right. Let's just erase that and try again. Okay. Now, again, our equation for direct variation is y equals a times x. We're trying to figure out what a is. And now notice I've got an ordered pair. I've got -4, 8. I also have, let's get a different color. Okay, I also have I got an x value, which can go here, and I have a y value, which can go here. So I'm going to substitute those numbers in. So I'm going to say 8 equals, don't know what a is, right? That's my whole point, is to figure out a. But I do know what x and y are. So we'll use orange, or let's just keep going with blue. And then x is -4. So again, we know how to solve this equation. All I have to do, a times -4. If I want a by itself, what I have to do to undo multiplication is to divide on both sides. Positive divided by a negative is a negative. Therefore, I have found my direct variation. So if I substitute a in, again, I got an answer. I'm going to substitute it in. My direct variation equation is y equals -2x. So we can write and apply a model for direct variation as well. So hailstones form when strong updrafts support ice particles high in clouds, where water droplets freeze onto the particles. The diagram shows a hailstone at 2 different times during its formation. So we can call this hailstone 1, and we've got a diameter, but we're not quite sure what it is. Okay, this is after 20 minutes. We also have a smaller hailstone after 12 minutes, and we know that diameter, okay, D equals 0.75 inches. So write an equation that gives the hailstone's diameter d, again it's in inches, after t minutes if you assume the diameter varies directly with the time the hailstone takes. So again, I'm trying to figure out what is my diameter. I don't know what that constant of variation is, okay? That's what I'm trying to figure out. But I do know that I have t time as well. So let's use our smaller one because again, I know what d is and I know what t is. We don't ever want to have two variables that we don't know what it is because that makes it a lot harder to solve. So I'm going to plug these in, substitute them in, equals, still trying to figure out a, but I know that t is 12. So again, how do you undo multiplication with division? 0.75 divided by 12 equals 0.0625. So my see here, my constant of variation is 0.0625. So again, if I were to write that as an equation, I would say the diameter equals 0.0625 times t. And now the second part is, well, we better figure out what is the diameter after 20 minutes. And because we got this nice equation, I can plug in 0.0625 multiplied by 20. Just going to move it over so I got some more room. And after I multiply that out, I'm going to find that d equals 1.25 inches. So again, what's my diameter after 25? 1.25 inches. And our last example is going to be use ratios to identify direct variation. Great white sharks have triangular teeth. The table below gives the length of a side of a tooth and the body length for each of 6 great white sharks. Tell whether tooth length and body length show direct variation. If so, write an equation that relates the quantities. So if I've got my tooth length t, see here, can we? No, that's okay. All right, so tooth length and then I have body length. And again, these are going to be tooth length, I'm going to call it T, and body length, I'm going to call it B, and they're both going to be in centimeters. So we got 1.8 for my tooth length, and my body length is 215 centimeters. And again, this would all be given to you in the problem. So again, I'm just writing down the problem for you. 2.9, 350, 3.6, 430, 4.7, 565, and my last one is 5.8. Make that point a little bigger, and 695. So what I got to do is I got to check the ratios. So again, I'm going to look at body length B to tooth length C. So my ratio is going to be body length over tooth, also known as B over T. So let's take our first term right here, 215 over 1.8, and that's approximately 119. Now I'm going to do that same thing for all of my problems. So 290 over 2.4, that's approximately 121. 350 over 2.9, that's approximately, again, the squiggly line means approximately, another 121. 430 over 3.6, approximately 119. And then I've got 565 divided by 4.7, approximately 120. And my last one is 695 over 5.8, which is approximately 120. So if I look at my answers, okay, 119, 121, 121, 119, 120, 120, they're not exactly the same, okay, but they are approximately equal. We're all kind of centering around this 120 number. So again, I could say that the correlation or the relationship to body length to tooth is equal to 120. Or again, if we wanted to rewrite it, again, multiplying t on both sides, b equals 120t. So if I found a shark tooth, and I could multiply it in centimeters by 120, and I could estimate or approximate how big that shark was. Kind of scary.